well, okay, so lesson 3-4, part 1 is long division. Now, eventually we're going to be dividing our polynomials using long division. However, if I jump right into that right now, do we remember how to do long division by hand without the calculator?
Nope.
Probably not really, okay? Some of you a little bit more than others, but there's a lot of gaps. So we're going to do this problem by hand, come up with an answer, and then we're going to translate our long division skills that you learned back in what, 4th grade? Something like that, into long division of polynomials, okay? So now, 96,456 divided by 25. How do we set this up? Valid question, right? Important question. There's my help. What goes in, what goes out, Ruby?
25 out.
Okay. 96,456 is what we are dividing into. We're dividing by 25, so that goes out. Yes? Bless you. Okay, what do we start with? How many 25s? So it's 2 digits, so we're looking into 2 digits, right? How many 25s in 96? 3. Okay. Where do I put that 3? Okay. Because we're dividing into 3 digits, or 2 digits, sorry, that 3 goes above the second digit. Then what do I do with that 3?
Subtract it from 96.
Subtract the 25 times 3.
Okay, so we're going to take this 3, and we're multiplying it by 25, right? And we're going to put it here. 3 times 25 is 75, and then we're going to subtract. And some of you are like, oh, this is basic, I know this. But if you don't remember these skills, long division with polynomials is going to be impossible. So 96 minus 75, 21. Then we carry the next number down, carry the 4 down. How many 25s into 14? I'm going to go with 8.
Probably 8. Well, there is 6 of them.
4 quarters in a dollar. So 8 quarters in $2.
4 25s. 4 25s.
Okay. When I would work with 25s, I automatically go to quarters. So 8 times 25. Well, 8 times 5 is 40. Carry the 4. 2 times 8 is 16. Plus the 4 is 20. And then again, we subtract. 214 minus 200? 14. Then? I am writing too big, I guess. 25s and 145.
6. No.
Almost 6, but not quite, right? So 5. 5 times 25, so 5 times 5, 25. 5 times 2 is 10, plus the carry 2, 125. 145 minus 125 is 20. And then carry down the 6. 25s and 206. 8 times 25 is 200. We've already been there, done that. 206 minus 200? 6. Okay. Now, if we wanted to keep going, we could put a decimal point and add zeros and drop the zeros and so on and so forth, right? However, when we're dividing polynomials, we're not going to have decimal answers. Okay? So, when you were in elementary, what did you call this? This was a remainder of 6, wasn't it? Okay? So, a little bit of vocabulary. This is my remainder. What is this 3,858 called? Quotient. Answer to a division problem is a quotient. Okay. And then if you didn't go on to a decimal, at one point you were just told you wrote R6, right? Remainder 6. What's the other option? Not a remainder, not a decimal, but can we express our answer with a fraction on it? What is it with a fraction? 3,858 and remainder of 6 over the divisor of 25. Does that ring any bells?
No.
We don't remember the fraction part?
Uh-uh.
Okay. That was one option you had, kind of after you learned remainders, probably before you did decimals. You can express your answers, 3,858 and 6/25. Okay. There is a decimal answer, but I don't care about the decimal answer today. Okay. My hope is that reviewed long division a little bit. Okay. The fact that you're dividing in, subtracting, repeating the process over and over. Because we're going to look now, okay, how do we use long division? Divide polynomials like this. Okay, so in this case, 4x squared plus 23x minus 16 divided by x plus 5. The question is, what is the quotient and what is the remainder? Okay. Well, it says long division, yes, so what should I see on your paper?
What is this called?
I call it a division box. Is there an actual name for
That's
it?
what I think.
To me, it's a division box. I don't know if that's proper vocabulary, though. Okay, what goes in, what goes out?
This x plus 5 goes out.
We're dividing by x plus 5, so that's going to go out. That's my divisor. We're dividing 4x squared plus 23x minus 16, so that's going to go in. That's my dividend, if you will. We're talking proper vocabulary here. Okay, now, with this in mind, first of all, one thing I will point out, and it'll come up more, I think probably in the backside. You always want to make sure you have all your terms existing, right? So I have x squared, I have an x term, I have a constant term. I have an x term, I have a constant term. So I have all my place values taken care of. We are officially dividing, there are two terms out here, yes? So we're kind of going into two terms. But here's what I want you to look at. In elementary, we kind of said, how many times does this go into this, right? So we're kind of thinking, how many times does x go into 4x squared?
We're distributing. Is where it-
I'm not sure. Maybe, depending on what you're thinking. Okay? So when I say how many times does x go into 4x squared, I don't usually get the right response. That's why I'm debating. But think about it. When I say how many times does 25 go into 96, I'm really asking you what number times 25 is going to give me 96, right? So here, what I'm really asking you is what number times x, or what value times x is going to give me 4x squared. 4x, okay? So, little side note here. It's x times what is going to give me 4x squared. Now, several people came up with the 4x pretty easily. Awesome, great. If you're thinking, whoa, how'd they come up with that? Like it's not clicking for you. What's the opposite of division? Or multiplication?
Division.
Division. Ask yourself, what is 4x squared divided by x? And that is 4x. Now, where do I put this 4x?
Opposite. Squared.
Not on top of the 4x squared because we're dividing by two terms. So we want to count over two terms. So properly set up, my 4x goes over the 23x because dividing by two terms into the first two terms. Also something to look for, it will always end up being over a like term. Okay, that's just how the setup also works. Okay, now, once you have your number up here, what should we do with it? Not yet. What are we going to, what are we subtracting?
4x from 4x squared.
No.
I don't know.
Did we subtract the 3 from 96 up here?
So we gotta multiply.
We had to multiply it, yes? So we're going to multiply. We're going to take 4x and we're going to multiply by x plus 5. Okay? So we're going to take this 4x here and we're going to multiply by x plus 5. Think distribute in a way. What is 4x times x? 4x squared. What is 4x times a positive 5?
25.
Plus 20x, yes? So I've taken my 4x and multiplied it by x, 4x and multiplied it by 5. So you're multiplying by each term. And then we're going to set ourselves up to, now I'm ready to subtract. Okay? 4x squared minus 4x squared.
Cancels.
Cancels. It should always cancel if you've done this correctly. That's the whole design. 23x minus 20x.
3x.
3x. Okay? We've done our subtraction. Next we will
Bring it down to 16.
bring down the minus 16. Repeat the process. This time, you're asking yourself x into 3x. How many times does x go into 3x? Or better put is, and I kind of used up a lot of room here, x times what is 3x? And when we say x times what is 3x, when you turn it into division, 3x divided by x is 3. So I'm going to put this 3. You either have to put plus or minus 3. Since it's positive 3, I'm going to put plus 3. And what are we going to do with that 3 now?
Multiply.
We're going to multiply. Yes, we're going to do 3 times x plus 5. So if you need to, think about it as a distributive, right? 3 times x is
3x.
3x. 3 times 5?
15.
15. And then we are ready to subtract. 3x minus 3x?
Cancel.
Cancels. Negative 16 minus 15.
Negative 1. Negative 31.
Negative 31 because we are subtracting, right? So you have to think of this, it's negative 16 minus 15, right? Because this is not adding, this is subtracting. Because that's how long division works. So that is a negative 31. Okay, what did this problem ask for? What are the quotient and remainder? What's my quotient?
4x plus 3.
Okay, that answer to the division problem there, which is 4x plus 3. What is my remainder?
Negative 31. X plus 5.
If they just ask for remainder, they just want the negative 31. If they just ask for remainder, they want the negative 31. Now, if they want you to write this as an answer, this whole answer is 4x plus 3. And then how do we express the remainder within the answer? It's going to be the negative 31 over
X plus 5.
x plus 5. Now, here's the deal. You can think of it as adding. You have to either add or subtract the term. So you can think of it as adding negative 31 over x plus 5. But better than adding a negative is to write it as subtracting. And so if you're putting an answer in Savas, they'd probably want to see 4x plus 3 minus the 31 over x plus 5. Okay, so they would probably want to see that as your division answer. Okay? Okay, questions? Because past that we're reviewing long division here at this point. Now, curious, did you do long division polynomials in Algebra 1?
Maybe.
Don't remember this? Okay. And I'm not saying you did. I'm trying to remember if you did or not. So this might be more of a first experience.
It'd be
Maybe.
nice if you guys all, like, you taught Algebra 1 in if you taught us in Algebra 1 and Algebra 2, it'd be a lot easier. Because, like, we would know, or Mr. I mean, either way, I'm not saying you guys.
Yeah. And I've taught Algebra 1 before, that's the thing. The curriculum changes at times because I've taught this in Algebra 1 before.
I think you taught it to me.
When I had you in Algebra 1? That's possible then. See, but it's going to depend on the teacher too. It's going to depend on the teacher, the curriculum, what you have time for, all of that. So, okay.
I remember we spent a lot of time on one-step equations.
Okay. Okay. Find the quotient using long division. What am I setting up?
A division box.
A division box. As I set up my dividend in the division box, are all of the terms and pieces present? If it starts at x squared, do I have every term after that? X squared, x, and constant.
Yes.
Same thing when you start outside, when you set up outside. If I'm dividing by x plus 7, I have an x, and then I have a 7. Okay. You got a better idea of what you're doing this time? This one might actually be easier than the last one. I guess about equivalent. Where do we start? What are you asking yourself?
What do you have to do to x to get 3x squared?
Okay. What do you do to x to get 3x squared? Yeah. Or in other words, 3x squared divided by x is what? And that is 3x. Where do I put my 3x? Yeah. 3x goes over the 29x, 2 reasons. 1, that's its like term. 2, I'm dividing by 2 terms, so I should be 2 terms in. Now what do we do with this 3x? We're going to take 3x and multiply by the x minus 7. 3x times x is 3x squared. 3x times minus 7, minus 21x. And now we're going to subtract. Good news, 3x squared minus 3x squared is, cancels, 0. Negative 29x minus negative 21x. I think I want to side with the negative 8x. My brain's processing too. Negative 29 minus negative 21. There's the visual, right? So negative 29 plus 21. Okay, now what? Bring down 56. And how does x become negative 8x? In other words, what is negative 8x divided by x? And that is negative 8. We're going to put the negative 8 in our answer above the 56. And then you're going to take negative 8 and you're going to multiply, distribute. So it's going to be negative 8 times x minus 7. Negative 8 times x is negative 8x. Negative 8 times negative 7 plus 56.
Yeah.
And last step is to subtract. What do I get when we subtract? There. They are identical. They cancel each other out. We get zeros.
So we don't have a remainder?
Right. Okay, we don't have a remainder, or in other words, our remainder is 0. Our quotient is 3x minus 8. The only way to write this answer is 3x minus 8. Okay. Okay. Catching on to long division a little bit?
No. It feels like something somebody made up.
It's really just a form of the long division you learned with just numbers back in like fourth grade.
It
So,
feels like such a stretch. Like, shouldn't there be a better way to do it?
well, we're gonna learn synthetic division on Monday.
Yeah, that's probably the better one.
Probably. And I will say synthetic division will only work if you're dividing by like a linear term, like an x to the first term. But it is much nicer and much quicker. Okay, backside. Find the quotient using long division. Now, there's a hint here. Don't forget to write the polynomials in descending order and fill in any missing terms. Fill in, that says any missing terms. I've been hinting at this in both of our previous examples. It comes into play here. Okay? So, what's my divisor? What's going outside of the box?
2x plus 3.
2x plus 3. That's an x term and a constant term. Perfect. What goes inside my box? Now, what's the catch? Okay, so 8x to the third plus 27, generally speaking, goes inside my box, yes?
Yes.
Now, I keep saying make sure you have all terms covered. So after an x to the third term, what would you expect to see next?
X squared.
X squared term. Do I have an x squared term? No, so we're going to put a placeholder in there, and we're going to say plus 0x squared. What would you expect to see after an x squared term?
Constant.
No, you're missing one.
Oh,
X.
X to the first. Do I have an x to the first term?
No.
No, so I'm going to put in a 0x. What do you expect to see after an x to the first term?
constant.
A constant. Do I have a constant?
Yes.
Yes, then write it down. So, plus 27. Now, and here's what I'm going to say. Can you do this without the placeholder zeros? Yes, you can. It just, things aren't lined up as nicely and it gets a little messier. Okay? So if anyone says, oh, you don't have to have those zeros, not going to argue. But this will make life nicer. Okay, you know where to go, yes? What do you know? How do we make 2x become 8x cubed?
Squared.
4x squared. Okay. And where's that 4x squared going to go?
On top of the 0x squared.
On top of the 0x squared. For two reasons. One, that's where its like term is. And two, we're dividing by two terms, and now I've counted in two terms. Are you all with me on that? That 8x cubed divided by 2x was going to give us the 4x squared? Okay, what do we do with 4x squared? We're going to distribute it into the 2x plus 3. So 4x squared times 2x, 8x cubed. 4x squared times 3, 12x squared. And now we're going to subtract. 8x cubed minus 8x cubed cancels as to be expected. 0x squared minus 12x squared. Minus 12x squared. 0 minus 12 is negative 12. Okay. Next. Okay. It's a 0, but we're still going to bring it down here because it's a placeholder. And it's going to make life the easiest. What do you have to ask yourself?
Do 2x cubed. Well, negative 12x squared.
Yeah. 2x times what is negative 12x squared? Negative 6x, yes. Or negative 12x squared divided by 2x, right? So that's a negative 6x that I'm putting, should just go in the next position, which goes over its like term, right? Take the negative 6x and multiply, distribute. Negative 6x times 2x. Negative 12x squared. Negative 6x times 3. Minus 18x. And subtract. Negative 12x squared minus negative 12x squared, cancel. 0x minus negative 18x. Minus negative is going to make it positive 18x. And lastly, bring down 27. What do you know about 2x into 18x? Yeah, 18x divided by 2x is going to be 9. What do I do with that 9? Put it on top of 27 and then multiply. 9 times 2x, 18x. 9 times 27, or 9 times 3 is 27. Okay. And you subtract and remainder of 0. What's my solution or my answer? 4x squared minus 6x plus 9. Now, I have a note here on this problem. I have a feeling that means it comes up as part of a homework answer, if I had to guess. Okay. We have a remainder of 0, yes? And we'll talk about this more Monday when we talk about our synthetic division. But when you have a remainder of 0, what that means, this divided nicely, didn't it? And this factors is what it means. If we were to take 8x cubed plus 27, it would factor into 2x plus 3 and 4x squared minus 6x plus 9. I know that because there's a remainder of 0. This is a sum of cubes. If you didn't want to do long division, you could have factored it and found out that one factor is x plus 3 and the other, or 2x plus 3, and the other factor is our solution. So, with that in mind, they must have you write it in factored form. Okay, so I'm going to put a note down here at the bottom so you have this information when you go to do homework. Because the remainder is 0, okay, 2x plus 3 is a factor of 8x cubed plus 27, okay? So because the remainder is 0, that makes 2x plus 3 a factor of the original divisor. With that in mind, and I think this is the reason I'm writing it, factored form. If you are asked to write in homework factored form, your factored form is that you're going to take that original dividend, so 8x cubed plus 27, and its factored form, one of the factors is the 2x plus 3, and the other factor is our solution of 4x squared minus 6x plus 9. So if you see that in homework, go for that. Okay? Thank you. Okay?
Payday.
It is payday.
Logan's getting ready to get spoiled.
Now, which is better here, the payday or the Reese's?
Probably the payday. Probably.
In the moment, though, I don't know. I paid bills last night. The money's already spent. You know.
You can't eat money.
Exactly. Chocolate and peanut butter?
Reese's don't taste good to me since I got COVID.
Oh, that's a bad taste to lose.
It's the worst part
That
of
is
my
a
life.
bad one. Okay, one more example. Find the quotient using long division. I gave you another hint here. Watch for descending order, yes? Watch, make sure you have all terms covered. So, now, are you to the point where you guys can lead me more?
I mean, yeah, but it's easier if you just.
It's easier if I just lead, huh? Trying to prepare you for homework. Okay, so in the box. 16x to the fourth minus 85. 16x to the fourth? What needs to come after that?
16x to the 0 to the third.
Okay, we need some zeros in here. After a fourth, there should be a third. So 0x to the third. After the third, there should be a second. After the second, there should be a first. After a first, there should be a constant, which is minus 85. Okay.
My should not be this long.
16x to the fourth plus 0x cubed plus 0x squared plus 0x minus the 85. Now, be careful what goes outside. Okay, here's the catch, guys. 4x squared plus 9. What comes after a 4x squared? X to the first. Do we have an x to the first? No, so this is a situation where you have to also fill in a 0x here before your plus 9. Okay, now, we're dividing by 3 terms here. Just changes things slightly. Same general idea. 4x squared into 16x to the fourth. So 4x squared times what is 16x to the fourth? 4x squared. Where am I going to put that 4x squared?
0x squared.
It's going above the 0x squared because that's where the like term is. And this time, how many terms do I have outside I'm dividing by? 3. So how many should I count over? 3. Okay, I don't know. Do I still need to be writing 16x to the fourth divided by 4x squared equals 4x squared? Is that helping some of you maybe? Maybe. Okay, I'm going to keep writing because I think it will help some. What do I do with this 4x squared? We're going to multiply. So we're going to take that 4x squared and distribute by 4x squared plus 0x plus 9. Okay, 4x squared times 4x squared. 16x to the fourth. 4x squared times 0x. It's a 0, yes? I'm going to write it as 0x cubed, but it's just 0. Okay? Yeah.
Okay.
But I'm saying you could just write it as 0. You don't have to have the x cubed on those. It just helps with placeholders.
Yeah, it makes it a lot easier.
Makes more sense. 4x squared times 9. 36x squared. Okay. Subtract. 16x to the fourth minus 16x to the fourth.
Cancel.
Cancels. 0x cubed minus 0x cubed.
Cancel.
Added bonus, it cancels. 0x squared minus 36x squared.
Minus 36.
Minus 36x squared. Okay, what do we do? Officially, you bring down the 0x. Now, what's the catch here?
There's 3 terms, so can't bring down the negative 85.
Yeah. So right now, technically I'm trying to divide into 2 terms, but I have 3 terms. It doesn't really work. Technically, what's going to go right up here? We can't do anything right now, so if you want to keep everything in order, you don't have to put in your answer, but you can think about putting a 0x up there. Because we just can't do it right now. We don't have the right term, so there's a 0 placeholder. And then go ahead and bring down the minus 85. Now, can I do 3 terms into 3 terms?
Yes.
Yeah. 4x squared into negative 36x squared. So what is negative 36x squared divided by 4x squared?
Negative 9.
Negative 9. Negative 9 goes up there. Still matching up with placeholders, isn't it? Take the negative 9 and multiply times 4x squared plus 0x plus 9. Negative 9 times 4x squared is negative 36x squared. Negative 9 times 0x, 0, 0x. Negative 9 times 9? Minus 81. And subtract. Negative 36 and negative 36 cancel when you subtract. 0 and 0 are 0. Negative 85 minus negative 81. Mm-hmm. Negative 85 minus negative 81, so you're adding negative 4. Okay, what did it say? Find the quotient. Didn't ask me what the quotient is, doesn't ask me what the remainder is, it just says find the quotient. So find the answer. How am I going to write this answer? 4x squared. Do I need to write the 0x? No. Minus 9. If there's a remainder of 0, we're done here. But there's not a remainder of 0, so how am I going to write this? Since it's negative, I'm going to say minus 4 over the 4x squared plus 9. Okay? Okay. This is part 1. This is long division. I need you to practice long division. Okay? I need us to get a feel for it. So, you should have lesson 3.4 part 1 available on Savas. Practice with long division. Okay? On Monday, I'm going to be introducing part 2, which is synthetic division. Okay? Synthetic division, I think after wrestling with long division, you'll appreciate. Okay? You'll appreciate it.